In this video, I'm gonna find the derivative of e to the power x. So we want to use the definition of derivative, which is this, to find the derivative of e to the power x. So derivative of a function is defined as limit h approaches 0 f of x plus h minus f of x divided by h. So my f of x is e to the power x. So f of x plus h is going to be e to the power, replace x with x plus h. Okay, so now I'm going to take these two values and plug it in here and simplify. So this is going to give me limit h approaches 0 f of x plus h, which is e to the power x plus h, minus f of x, which is e to the power x, divided by h. This is going to be equal to limit h approaches 0. Now e to the power x plus h, I could write it as e to the power x times e to the power h. And you remember your rules for exponents, right? So a to the power m times a to the power n is equal to a to the power m plus n. Or if I go the other way around, it's going to be a to the power m plus n is equal to a to the power m times a to the power n. So this version of the equation I have used to go from here to here. Minus e to the power x, all of it divided by h, which is going to be limit h approaches 0. I could factor out e to the power x, right? That's going to give me e to the power h minus 1 divided by h. Now this is where we kind of run into a problem. I'm going to have to use something else that you may not know at this point. E to the power h, by the way, e to the power h, there is a different way of writing this out as a series, as a sum of bunch of numbers, okay? So this is going to be 1 plus h over 1 factorial plus h square over 2 factorial plus h cube over 3 factorial plus dot dot dot. In case if you don't remember factorial notation, so let's say 3 factorial is actually 3 times 2 times 1, which is 6. 5 factorial is 5 times 4 times 3 times 2 times 1, and it comes out to be 120, I guess, right? 120. And in general, n factorial is n times n minus 1 dot 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 to 3 times 2 times 1, where n is a positive integer. And also, as a side note, 0 factorial, we define it to be 1. So if we use this version of the e to the power h, what we get is this. Now we can kind of like simplify it. Oh, I forgot something here. This thing, let me put it inside. This minus 1. Okay, this minus 1. Minus 1. And this one and this one is going to cancel. Now I have to simplify this term. Upon simplification, this is what I get. So look, what I have done here is this. I have e to the power x. This is the e to the power x. Then 1 over h, I just put it here. I just switch these two terms. Now, from this, I could factor out h, because negative 1 and positive 1 cancelled out, and all the remaining terms have h. So if I factor out 1h, this is what I get. Now this h and this h is going to cancel out. Then I'm going to get a simpler version of this expression. And this simpler version is this. Now look, if I evaluate the limit, all these terms are going to go to 0. Why is it going to go to 0? Because all of them have h in it. Because as h approaches 0, all these guys are going to go to 0, leaving me behind with just 1. So that tells me that this limit is going to be evaluated to e to the power x times 1, which is nothing but e to the power x. So here is an interesting thing I want you to remember, or I want you to pay attention, which you will know for sure in the future, and we probably will take it for granted, is this. The derivative of e to the power x is actually e to the power x. So that means f prime of x, in our case, is going to be e to the power x. And this is the only function for which the derivative is the function itself. Okay? So this is how we find the derivative of e to the power x. I hope that this discussion was helpful. Thank you very much.